Hello everyone, this is Mr. Companion for the New York State Physics Regents curriculum. Today we're going to explore PhET's wave on a string simulation. Then we're going to set up the simulation for our universal wave equation investigation. So when you first start the simulation, you're going to be greeted to a wrench holding a string. You have three options to begin: manual, oscillate, and pulse. Now there are other features we can adjust. For example, in the upper right hand corner you have fixed end, loose end, and no end. If you click on loose end, you get what appears to be a metal rod with a ring around it, and the ring is attached to the string. So let's send a single pulse. You'll notice that the wave moved up, or I should say the string moved up and down again. So this kind of holds it in place and it brings it back to the midline. And then lastly, we have no end. So there's your open window, your open door. And in fact, if we go to oscillate, you can see that wave just propagates forever. If you were to do something like place a fixed end in the way, you would start to get reflections and the wave would come back. So we do have a few additional features that we're going to take a look at. But before we do so, I want to draw your attention to the bottom right-hand side of the screen where we have this orange circular arrow. When you give that a click, that reverts everything back to the base settings from when you first started the simulation. So in case you want everything back to its default status, that's how you get there. Now you might have noticed in the bottom left-hand side of the screen, something went missing. To get it back, I'm going to click on Oscillate. Because we're in oscillate mode, now you'll notice we have amplitude and frequency available. Now what are those? Well, amplitude, as you drag to the left, you'll notice that the piston just doesn't move very high. It goes up a certain amount and then it comes back down. As I drag my amplitude to the right, you'll notice the piston moves a greater amount. I'm just going to leave it in the middle for now. Next, for frequency, you'll notice that as we drag that to the left, the speed of motion of the piston drops. And as we drag the frequency slider to the right, the speed of the piston increases. Next, we have two more very interesting tools that we can play with. It's damping and tension. Damping, as we slide to the right, you can see we have lots of damping. Damping is really the act of the string absorbing some of that energy. And if we move to the left, it's really like a perfect medium. It allows that wave to propagate without any slowing, or without any absorption. And then lastly, we have tension. Tension is really just how tight is the string being pulled. If it's being pulled very taut, you get one type of wave. And if it's being pulled not so tight, slack, relatively loose, you'll see it changes the pattern of the wave. So next we have three more very important tools. Let's start off with the reference line. Now with the reference line, it's kind of like a laser, and it can give you a straight line that you could reference other points to. Now I'm going to increase the amplitude just a bit, and I'm going to increase the damping. By doing this, you could see that by putting your reference line at the very top of motion for the piston, you can see that each subsequent wave that comes off as the wave propagates away, it decreases in amplitude, and that makes it very obvious. In some cases, say for example here, you might not be sure if it's really dropping, but by having that reference line there, it makes it more clear. Another tool we use is the rulers. So rulers can be used to measure things like, for example, wavelength. Now, trying to use a ruler to measure this wavelength is pretty difficult. So you could slow it down, but there's actually one more better that you can do. You could pause the simulation. Now, by pausing the simulation, You can take your ruler and line it up. You can go from peak to peak, or you can go from where it crosses the baseline. So here we can see in an upward motion, we're crossing the baseline, and over here we're moving across the baseline in an upward motion. And this ruler, if it's in centimeters, which it is, each one of these intermediate points is zero point 0.2 centimeters, or 2 millimeters. So let's try and figure out how far one wavelength is in this case. This would be 1 centimeter, 2 centimeters. It looks like it's just shy of 3 centimeters, maybe about 2.9 centimeters. Now, I want to take a moment to just tell you these green dots really have no purpose to them, no meaning, no special meaning. There's nothing special about them. They're just there to help you see the wave a little bit better. You also have this little click forward feature, and it'll just allow you to move forward in time ever so slowly if you didn't pause in the right spot. And then lastly, we have a timer. Now, to run the timer, all you got to do is hit the play button, and you'll notice it didn't move. The reason why the timer is not starting is because the simulation is paused. The moment I unpause the simulation, you can see that the timer continues. I also want to note that the timer is running at a slower speed because we're in slow motion. It's running at about 1/5 speed. If I kick it back up to normal, you can see the speed increases. All right, with that said, we're going to set up everything for our universal wave equation investigation. So I'm just going to take the information directly from the slides. I want you to adjust the settings to oscillate, no end, medium tension. We're going to set it to no damping, a frequency of 1.0, and an amplitude of 1 centimeter. Remember all the tools that you have available to you, they're always there. Wish you luck on this investigation. Remember, fiddle around with every little adjustment you can find on here. You can't break it, and you always have that orange button to bring it back to the beginning. Bye-bye.